Hello, my name is Victoria Binney, and my project is entitled Using Machine Learning to Empirically Evaluate L1-L2 Grammar Transfer Theories. To provide a brief background, grammar is a fundamental component of language, and as such, grammar learning is thought to be equally fundamental to the language acquisition process. However, there is debate about how second language learners process grammatical features not also found in their first language, with some competing linguistic theories asserting that L2 learners can acquire native-like processing to these unique features, such as the full access full transfer theory, and with other theories such as the interpretability hypothesis arguing the opposite.
To investigate these theories, we take a neuroimaging approach, which enables the direct observation of the neural responses that reflect processing occurring before and during a behavioral response. Previous research has analyzed event-related potentials, which are time-locked voltage deflections elicited by the processing of specific types of stimuli, such as processing grammar violations. However, previous ERP research has produced conflicting findings regarding whether L2 learners can acquire native-like grammatical processing to features not found in their native language. And we note that these conflicting results may be attributed to Tanner's 2019 finding that the traditional ERP method does not account for individual variability in grammar processing, even among highly proficient native speakers. And seeking to remedy this issue, we use multivariate pattern analysis, or MVPA. Rather than analyzing through a univariate approach, MVPA treats each channel voltage from each trial of a participant's EEG data as its own discrete data point in a multidimensional space and finds correlations between these data points to look for the dimension that best separates them. And that leads to my two research questions, one being, do participants show neural sensitivity to grammatical features that are shared between English and Spanish? And two being, do participants show neural sensitivity to grammatical features that are unique to Spanish? Now on to my methods. We recruited 52 participants from third and fourth semester university Spanish courses who were considered to be low proficiency L2 Spanish learners on average, as assessed by proficiency measures. The EEG recordings were collected during a grammaticality judgment task, during which participants saw 244 total sentences in Spanish per experiment across the following three grammatical conditions: subject-verb agreement, number agreement, and gender agreement, the last of which is found in Spanish but not in English. To analyze the EEG data, we pre-processed it in MATLAB, and then following that, we ran the MVPA analysis using the Atom Toolbox, which was also available in MATLAB, and then we ran an additional exploratory analysis on the participants with the highest scores on the grammaticality judgment task. So now before I move on to my results section, I just want to slow down here and explain more about what will be presented. So just to reiterate, the goal here and using MVPA was to distinguish between the participants' brain responses to grammatical versus ungrammatical. So for example, the difference between these potatoes and these potato. And as you can see here in this plot, the red coloring denotes significantly above chance decoding accuracy, while the white coloring denotes chance accuracy, and the blue coloring denotes below chance accuracy. And so here in this plot for number agreement in the English language, the red outlining suggests that participants are distinguishing between grammatical and ungrammatical between these time points. Now onto my results. As a reminder, my first research question asked, do participants show neural sensitivity to grammatical features that are shared between English and Spanish? So starting off with subject-verb agreement, we see in the plot to the left our participants' native responses to this condition. In the plot in the middle, we see that the overall cohort of participants did not show significantly above chance decoding in Spanish. And in the plot to the right, we see that the high proficiency speakers showed splotches of high accuracy decoding starting at around 750 milliseconds, but this did not survive correction for multiple comparisons. For number agreement, we can see the strong native response in the plot to the left, and then for the other two plots, we can see that while decoding for this condition was only significant for the high proficiency participants, we see that the overall cohort of participants also showed signs of high accuracy decoding. Now onto the second research question, which asked, do participants show neural sensitivity to L2 grammatical features that are unique to Spanish? We see here for gender agreement that while both plots contain some red splotches, neither contain the native-like patterning that was characteristic of the other conditions. In interpreting our results, we note that they support previous research in showing that second language learners are sensitive to grammar features shared with their native language, but not to grammar features that differ between their native language and their second language, which aligns more generally with the interpretability hypothesis. And more broadly, we note that MVPA sensitivity to neural signs of grammar processing makes it a promising analytical tool for future research. Thank you for listening to my presentation.